we're going to talk through another kind of system design question. We're going to use this to-do example a lot, just to try to keep some continuity on here. But say you're doing something like this. So you're building a to-do app. You need to communicate with the server so your to-dos are accessible across devices, because say you want to be able to do it on your phone and your, laptop. And also because if you have that feature we were talking about with content providers where you're sharing data, or you're sharing a to-do with another person, you want to be able to sync with that. So the feature you're trying to develop is that when you first open the app, you want to request the user's to-do from the server so they're up to date. While you're waiting for those to-dos to return, you also want to be looking at if there's any to-dos already in the database so you can load them. That way you can say, or like say you're offline and the network request ever comes back or something, you want to have something to show the user if you have anything in your database. So you want to be looking at that. Once you have that list of to-dos, you want to be able to show it in the UI whenever it's available. And you want to be able to say, okay, if it starts loading all my to-dos, I have a ton of to-dos, and I see the top to-do is the one I actually care about, I want to click on it. It's still trying to come back from the network, but I see that first to-do from the database. It shouldn't be blocking me from doing that. I should be able to click things if it's already loaded. So take like 2 or 3 minutes to start thinking about, or also like give everyone like a minute or two to just think about, okay, what are these requirements? Collect my thoughts. What might I want to use for this? And why? And then we're going to talk about what that might look like in a second. Let's go over here. This is going to be our like whiteboard for the day. Let me see if I can actually share it with you guys, so we can collaborate. Put it in everyone. Okay, so we talked about those requirements are, we want to request for the list of to-dos. We want to load the to-dos from the database while we're waiting. We want to then be able to show those to-dos. And we don't want to like completely block the user from interacting with the app in the process. So what might we want the thread model to look like for this? So we have our main thread by default. This is like the app opens here. And then where do we want? We have a request and database read, and then loading data, and maybe a user click. Where do we want all of those on our threads? Does anyone want to take a guess?
Yeah, we want a worker thread immediately when user launches the app. Before we draw the recycler view, we will kick that worker thread, try to fetch the data from either from API or from database, from a repository.
Cool. So do we want, so you mentioned a thread to do API or the database. Do we do that here on the same thread? And if so, which one do we want first?
It depends on the business logic, actually. If we want to show offline data, and whenever I get the latest information from API, if I can update the UI, then first I'll create like 2 threads, one for database reading, and then I will update the UI instead of showing spinner until API loads. Once the API loads, and I'll refresh the recycler view with the diff utils, so only the new changes will get reflected.
Sweet. Yeah, that makes sense to me. So what you were saying is basically, rather than having one thread that does both, we might want to have 2 threads. That way we can be kicking off the database and the API call. And if this is our main thread, Working on my computer whiteboard writing here. We open the app. We're going to kick these off. The user isn't blocked from doing anything because this all happens on the background thread. We can be showing whatever other, UI we might have of, say, there's like a nice fun background or like a settings page or whatever it is. When the database returns, so we have these two background threads. You mentioned got the API. Yeah, go ahead.
Sorry. Yeah, when database, reading it from database is pretty quick, right? Mostly I'll go with like pagination. I'll read like few items, maybe 25 or something, and then I'll draw the recycler view. Like I'll set the data to adapter. Then once API response comes back, if I need to refresh, then I'll refresh the recycler view.
Sweet. And real quick to circle back to what we talked about earlier, if you are doing like the purely Android-y way of reading from the database and you mentioned like paginating, what might you use to read from that database in the app?
We are using a RoomDB, like I'll use a Room database.
Room. Cool.
Yeah.
Probably going to be what you want to use, but if you're like going pure like old school, you might use a cursor loader, the content provider piece we talked about. But yes, Room is at this point Android architecture, so definitely an easier choice. Okay, API. So then you have the API, it comes back, you'd update it here. The user wants to click on the first to do here, and it will need to make a network request then to get the like details of that to do, because they see, oh, okay, actually this like to do that I looked at yesterday was the one that I actually care about. What's going to happen at that point? You don't have to answer the question unless you want to. Somebody else can also check.
Sure, I was. It's okay.
Yeah, go ahead. If you're up for it, you can also answer.
Yeah, I mean, now core we are using like coroutines heavily. It's like lightweight, right? So we will fire like I'll fire one more thread in coroutine, and then we'll get those details. If you need to update the DB, update the DB and show that to do details.
Sweet. Yeah, that makes sense to me. Anyone have questions on this?
So just a question on when we get the updated data. So the last thing that we spoke about was basically when we get the latest data from the API. So our the next job is to basically update the DB, right? So that's what was about the coroutine, right? Just to understand that part.
Yeah. So depending on the way your app is structured, a lot of times you'll be loading, like the UI will basically be hooked up to the database. You have this cursor loader. And so what you might want to do is basically when the API comes back with new data, you update the DB. And then from there it says, oh, there's new data in the DB. We like update the UI.
Okay.
Probably like the most kind of correct way to do it. Let me delete this because it's a bad connection of threads. But basically, yeah, you'd say, kick off the DB on a thread, kick off the API on a thread. DB will show it to the UI. You might have this connection up here, and then you have when the API comes back, update that DB, then say, okay, cool, there's like new data in the DB. Let's update the UI.
How does that happen, Allison? Like, how do you know there's new data in the DB so that UI needs updating? Is there a listener or something, callback thing like that?
Yeah, so a lot of times if you have an adapter, like it's kind of the setup there that like it is essentially a callback. It's like listening on if there's any new data in the database. It has this like hook kind of set up, like hook into the database to say, okay, there's like new data here. Let's refresh. Like live data too is like an Android architecture thing in the past few years. But yeah, it's usually basically you're sort of listening to is there data available in the database? If it changes, update the UI. You might have like a notifier. There used to be like notifiers, like you do more manually, but now it's usually more kind of built into some of the infrastructure there.
Okay, thank you.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today